Hello smart contract maxis, welcome back to yet another exciting tutorial. And in this tutorial we are going to build a fully ERC-721 compile based smart contract with gas optimize, which is NFT smart contract and minting functionality. And we will build it, we will test it. I will show you some of the best test cases, how you can write as a smart contract developer, and we will deploy it on rootstock test network. And the features of our smart contracts will be our standard will be ERC 721, which is full ERC 721 compliance with metadata support. We will use some guess optimized tricks, the model solidity patterns for efficiency. I will have access control, owner only functions for administration task, minting limits and payment integration, withdrawal function, and so on. So here we are on rootstock.io website. If you want to explore the rootstock documentation, you can go here dev.rootstock.io, and you can learn about the rootstock. What are the tools you can use as a builder, and how you can build. They have really great and comprehensive documentation. Here you can see EVM compatible tools, how you can get RBTC, which is their rootstock blockchain's native currency, some quick starts guides, SDK integration, and RIF, the which is rootstock infrastructure token. These tools, RPC API bridges, and so on. You can join their Discord community to ask technical and also questions related rootstock. Before going ahead, let me tell you prerequisites. You must have at least basic understanding of NFT and Solidity. We are going to use Foundry, so make sure you have Foundry installed in your system. So you can go get foundry.sh, get started, and in the sidebar installation, and install it according to your system. Also make sure you have in MetaMask installed and extension added to your browser, and these networks, rootstock test network, rootstock main network, added to your MetaMask. To add, just go to MetaMask here in advanced search, and here you will find adding rootstock to MetaMask programmatically. Configure MetaMask wallet to rootstock, and I clicked here, and you will find two of the buttons here: add rootstock mainnet to MetaMask, add rootstock testnet to MetaMask. And by clicking these two buttons, you can add these networks to your MetaMask. And let's get started. Make sure you have faucets. We are going to deploy on rootstock test network, so we must need to have a test RBTC. So copy your address and go to faucet.rootstock.io. Copy your paste your address here. Check I'm not robot, I'm indeed not robot, cars, and let's verify. Please select all the images, cars, the one, two, let's verify. Let me refresh it, and there we go. And I'm not robot, and get test RBTC. Let's wait for some time, some moment, 30 seconds, while transaction being mined, and we will get some test RBTC. So without wasting a time or further, let's get started and start writing our smart contract. We will first start, we will first initialize the Foundry project. We will build ERC-721 smart contract using OpenZeppelin with the help of OpenZeppelin library. And after that we will test it. We will write a lot of tests. uh, Due to test, this tutorial will be so long, but I will show you some of the best test cases using how you can use Foundry and same EVM tools to build on Bitcoin. And also, if you want to explore more about rootstock, these are the some of the best fascinating concept, like merge mining and POPEG union bridge. You can go here, learn section, union bridge, POPEG, and merge mining, how merge mining works. and it's very fascinating stuff to study about the rootstock. So let's get started and start building our smart contract. For that, I am on my desktop and create a new folder. Let's name it ERC-721. By the way, most of you know ERC-721 is a NFT token standard. So we are going to build this, open it in our VS Code. Let's expand it. And as I said, uh, we are going to use Foundry for this project. So let's initialize Foundry uh, project by running this command forge init. And as I also said, we are going to use OpenZeppelin library for smart contract. With the help of OpenZeppelin, we are going to use ERC-721 library, ERC-721 URI storage and ownable and so on. So let's install OpenZeppelin by running this command for install OpenZeppelin slash OpenZeppelin dash contracts, and let's hit enter, and let's wait while it is installing. While it is installing, let's delete these three files, counter.t.sol, also from src counter.sol, and also let's delete this one, counter.s.sol, and it is still installing. And let's create a new file inside the src directory, and let's name it my nft dot sol. Sol is the solidity language extension. We are going to use, most of you are the ethereum builders, and you as an ethereum builder can use the same tools, like same language, same tools, uh, like you build on ethereum, and say using same tools you can build on rootstock network. Rootstock is bitcoins, you can say DeFi layer, which is fully EVM compatible, and that's why you can take leverage of EVM compatibility and build on Bitcoin, which is the rootstock is Bitcoin's sidechain. With merge mining and Bitcoin's hash rate, you can leverage Bitcoin security and build on uh, rootstock test network. Great applications. So let's start writing our smart contract while it is installing. Yeah, you can see our OpenZeppelin contract version 5.3.0 has been installed, and let's set up our remappings to avoid some red lines from VS Code. To set remappings, let's run this command for remappings remappings dot txt, and hit the return or the enter on Windows. Let's pull it down, and you can see our remappings has been set. Foundry automatically generate the remappings.txt file, and it set all the files which we need. So let's start writing our smart contract first. Pragma Solidity license MIT Pragma Solidity, we are going to use 0.8.20 version. And now let's start writing our contract. Let's name it contract my NFT is let's as I said, we are going to build this ERC-721 smart contract. So let's import ERC-721 from OpenZeppelin. You can see here inside the library we have for standard library. Inside the live directory we have for standard library, which comes with Foundry, and we externally install OpenZeppelin contracts library. So let's import from ERC-721 from OpenZeppelin. How you can, we are importing named import. So ERC-721 ERC-721 from OpenZeppelin contract slash token, and thanks to copilot ERC-71 token slash ERC-721 slash ERC-721.sol. We also need to import ERC-721 URI storage. So yeah, thanks to Copilot, ERC-721 URI storage from OpenZeppelin contracts token ERC-721 extension and ERC-721 URI storage dot sol. We also need to import ownable, as we have some functionality as I promised from OpenZeppelin contracts slash access slash ownable dot sol. And with that, let's go ahead and copy the ERC-721 ERI storage is this, and let's make it ownable. Copy it from here and paste it here. That's it. So what is the warning? No argument fast constructor. I will add this, so don't worry, we will tackle entire error very gracefully. So let's first declare the state variables. Uint 256. If it doesn't make sense initially, just bear with me and you will get everything. Private, let's name it token IDs, token IDs, and we are not going to initialize this right now. We will initialize it very soon. So let's declare the constant variables now. Uint 256 public constant. By the way, this is the best practice. This is how you can follow me, and this is how you can follow the best practice of declaring constant variables. So max, let's name it max supply, let's say 10,000. 2 3 4, yeah, let's name now min price. So let's declare min price public constant, mint price, let's say 0.01 ether. And now let's go ahead and to track our mint count, let's declare mapping of let's address to uint 256 uint 256, and let's name it mint count, where it's c mint count. And now let's declare another state variable here, uint 256 public max mints for address, and let's say 5, and let's format the documents. What are the two? It is not formatting due to our error ether 0.0 ether. What's wrong? Expected maybe this is VS Code error. Let's ether. Now there we go. And now expected change, we will see this one as well. And now let's go ahead and let's initialize our constructor here, so we will avoid the upcoming errors. So let's declare constructor here, and inside the constructor, most of you know how constructor works. It calls only on deployment time. So let's copy ERC-721 from here and copy paste here. So best constructor, let's name it my NFT and NFT thanks to Copilot. And we also need to call here ownable, and inside the ownable we need to call message.sender, and that's it. There we go. Now our errors should go away, and we forgot to add the conf here. And now you can see we have still one error. This is the VS Code error. Let's not it will be go away very soon. And you can see here our all errors gone. Now let's keep writing our function. So in our contract we have the main function, main to address function, get total supply, get set max means for address, which is we, as I said, only owner, we have the governance functionality. Only owner can do some certain task, and we will also add withdraw, and which we will give only access to only owner. And let's start writing our functions, all the functions we're gonna write. So let's first write our first main function, which is already the copilot, my GitHub copilot suggesting, but we'll write our own logic. So let's start function mint, and inside the mint function we are going to take parameter as a token URI. So token URI will be a string memory and token URI, and let's make it external payable, and let's write functions body. So if we are going to add three conditions here first, and after that we are going to follow some CEI, check effect interaction, which is the professional way of smart contract developers to write. So let's add some conditions here. So first condition is to require a message dot value, should be greater than or is equal to mint price. Let's copy mint price here, mint price. Otherwise we will add the, we will revert the error here, insufficient payment. So let's write insufficient, not funds, let's make it payment. And now let's add another condition here, require the another condition is token IDs. Let's copy it from here. The condition is the token IDs should be less than maximum supply, otherwise we will revert an error, max supply reached, thanks to Copilot. And let's add another condition here, which is basically for the mint count. So let's copy this mapping here. The condition should be mint count of message dot sender should be less than max mint for address, max mints per address. Copy it from here and paste it here, otherwise it will be throw an error, max mints per address reach, and that's it. And these are our conditions. And now let's write our functions logics. Let's copy it from here, tokens. Now what it will happen, let's make it plus plus, and now let's take here a local variable uint 256. By the way, you know what are the token, sorry, local variables. So uint 256, let's name it new token ID, and let's say is equal to token IDs, and that's it. Now we are going to call here the safe mint function. I hope you got to where I am, what I am talking about, and why we installed OpenJeplin library. So let's call the save mint function here, save mint, and inside that we are going to pass message dot sender as an argument of the parameter and new token id, and that's it. Let's call here another function, set token URI, set token URI, and inside that we are going to pass new token id and token URI. Thanks to Copilot, and let's format it expected 29, which is just VS Courier. So I hope you got understanding where this save mint function coming from. And you can see here, as we are inheriting, I already explained in previous videos which their functions are coming for. We installed OpenJeplin library and we are importing ERC-721 from OpenJeplin. So inside that, whatever the functions we have, and so you can see whatever the functions we have, we can use as an inheritance. Let me go here and copy. So you can see all the functions we installed OpenJeplin library, and inside that library all the function token ERI, support inheritance, whatever the functions we need we can inherit, because we imported that contract here on the top of our contract, and we have access of all their functions and all the contracts, so we can use this here. So we are using this mint function. Let's go here and let's hover over this, and which takes two parameters, and we can use as the functions. So let's go ahead and let's keep writing our contract logic. So let's minted count, and inside that minted count we are going to pass message dot sender, and which is the plus plus, the minted font. Where this coming from, I will show you, so don't worry. The minted count, actually not the minted count, here we minted count, and I forgot to add there one as well, so bear with me, and that's it. So minted count, the mapping, now it should go away and declare the mint count. This is just VS Code error. And now let's emit an event here. So events are very important when you are connecting your smart contract to the front end, and when you are working with where you have to index and query data, and where you use the protocols like the graph, which is data querying and indexing protocol. They listen or contracts the transaction events. So events are very important in your smart contracts. So whenever you can possible, you can emit an event. So let's emit an event here. Let's name it NFT minted, because this is our mint functions logic, which is the very function mint. And inside, after happening all this logic, after checking all the conditions and executing this logic, calling these functions, NFT count, minted count will be set to message dot sender, and we are going to emit this event. So let's pass here NFT minted, and inside that let's pass message dot sender, and let's also pass new token id thanks to Copilot, and token URI as well. So let's token URI, and let's copy the here, and here on top both the constructor, let's make it event, and let's declare our event here that we have emitted, and let's address of the let's make it indexed, because if we use this for front end, use this smart contract for front end, it will be very convenient for us to show data. So index 2, and let's uint 6 index indexed of token id and string token URI. That's it, and there we go. Let's format the document, and here is our event, and let's keep writing our smart contract, and let's write our second function, which is the which I said mean to address. So let's start writing function mean to address, and let's make it external and only owner, external and only owner. Why this only owner and how this only owner coming from, I already explained in the previous video and in this video as well. So we are inheriting some contracts from OpenJeplin library, and which we have rights to inheritance rights to use this. So mean to address, which will take two parameters, address of the true, address of the two, and token URI. So let's string memory token URI, thanks to Copilot. And now let's check the our first condition here. So require, the condition should be the token IDs should be less than maximum supply, or the maximum supply reached, and that's it. That's our first condition. And now let's write the token IDs functions logic. Let's write functions logic token IDs plus plus. Let's take it local variables uint256, new token ID is equal to token IDs. Now let's call the segment and to, and inside the segment new token IDs, and the same set token URI and new token URI ID token URI, and the same emit function here. And let's format this, and what is the error, and the same logic we have implemented here. So you can see here NFT mean to address and mint functions are almost same here, almost, which is fully same. And now let's keep writing or the basic functions like get token total supply, set max min for address, and withdraw, and so on. So let's keep writing these small functions. Function, let's first write get total supply, and inside that we are not going to take any parameters. So let's make it external view returns uint256 and return token IDs, thanks to Copilot. Now let's write our another function, which is function set max means for address, and which will take a parameter of uint56 max means, and let's make it external and only owner, thanks to Copilot. And let's write functions body. So max means for address is equal to max means, let's copy it from here and paste it here, and that's it. And this is the very small function we have. And let's go ahead and let's write our withdraw function, which is very important function. Function withdraw with withdraw external only owner. And now let's declare here a local variable unity 256 of balance is equal to address of this file it is suggesting, right? But we are going to use our own logic dot balance, and that's it. Now let's keep writing. Let's add a condition here, require the balance, copy the balance from here. The balance should be greater than 0, otherwise let's revert the error here. No funds to withdraw. That's it. What is this error? Undeclared variable, which is VS code error, not from our site. BALANCE. And now let's add another variable here, bool of success. And now a space here is equal to payable of the owner, and let's call the owner, and we are going to use here the dot call function here, dot call, and inside that as a value of the balance, and that's it. Let's copy from here, and that's it. And now the condition here, require success. If it is success, otherwise withdrawal failed. That's it. So let's format our document. So you can see here, I can format from here as well. And if you want to format all the your, because since you once you write very comprehensive smart contracts, you are dealing with lot of contracts, and you want to format all the contracts at the same time, so you can use this command forge fmt, and it will format entire your smart contracts in the great manner. So far what we have done, so we initialized the Foundry project, we learned about rootstock and its sidechain, we get some faucets, we learned how to add rootstock testnet and mainnet to your MetaMask, how to get faucets, how to initialize the Foundry project, and how to install Open Zeppelin libraries, and how to write ERC-721 smart contracts importing with the help of Open Zeppelin libraries. We declare some state variables here, mapping here, and event. We have declared the constructor here. We have the main function, which is very gas optimized, and the same function logic we have mean to address function here, and we have three functions here: get total supply, set max means for address, and the withdraw, which is the only owner. So in this part we have built the smart contracts, and in the next part we will purely write smart contracts. We will rigorously test our smart contracts. We will write we have 1 2 3 4 5 functions. We will write more than 15 test. I will show you how you can test smart contracts very rigorously as a smart contract. You will write bad DAS test. I will explain you every single thing, and we'll write, we will of our coverage. So let's go ahead and I will show you how you can write test cases. But this video will be so long and you will be so bored, so let's wait for the second video, second part of this video, and I will show you there how to write best test cases using the Foundry. And at the end of this second part I will show you how you can deploy, we will deploy our smart contract on rootstock test network, and I will show you which is how you can deploy the smart contract. Not only deploy, but how rootstock the protocols the deployment is different from Ethereum, since you rootstock using EIP 1559 legacy London fork transactions systems. So I will show you there how you can use, how you can deploy the smart contracts using Foundry on rootstock test network. So with that, I am wrapping this up and I will see you in the next part. Bye bye.